So I went to Half Price Books the other day and found ODiffL Equations Applications 3rd edition, and it's by these guys Rice and Strange, so you know that it's completely trustworthy. And if we pop it open here, we can see that it's got this nice introduction that mentions my boy Gottfried Liebnitz, and you know that anything that mentions Gottfried Leibniz is for me, because you can't have Isaac Newton stealing all the credit, now can we? And if we go over to the introduction, we see it has this nice little this nice little one. This dy over dx equals e to the 2x. So we're gonna actually try to solve that using some really jankety physicsy math. Alright, so this is where the fun begins. We're actually going to evaluate this integral from the very beginning of what I was showing you, just dy over dx equals e to the 2x. This is just a great integral. So I'm studying to be a physicist, and every good physicist knows that a differential, something like this, it's just a fraction, and we treat it just like it's a regular old good fraction. So what we can do is multiply both sides by dx. Just take both sides, multiply by dx, and you cross out the dx's over here, and then you get dy equals e to the 2x dx. So you're probably thinking, hey, what do we do with that dy? Well, we just take it and we act like it doesn't exist. We just act like it doesn't exist. Kind of like a certain German guy who really helped with differential equation. But that's neither here nor there. So we write down our y equals e to the 2x dx. But wait, we're forgetting one thing. That's right, the squiggly integral sign. We forgot about that. So how can we solve an integral like this? U sub, we take our e to the u is what we have, and then we take our u is equal to 2x, and now we're going to continue to treat our differentials as though they're fractions. So we have our du, that's going to be equal to 2dx. So now we have dx equals 1/2 du by rearranging a few things around as though these were just variables. So now we substitute everything in. So we have y equals the integral of 1/2 e to the u du. And I hope it makes sense why we have a 1/2 and a du there, because we took that and we just replaced dx with 1/2 du. So I'm going to go over to the top here so we have a little bit more room in order to work out this integral. So we're going to put the 1/2 outside, actually, because you can do that if you just have a constant multiplier, and that makes this a lot easier. So we have e to the u. What's the integral of e to the u? With respect to du, of course. It's just e to the u. It's just e to the u. And we take that 1/2 and it just stays there. So we have 1/2 e to the u. And then don't forget that our u is equal to 2x. So we got to take our y equals 1/2 e to the 2x. So this right here is probably the most jankety physicsy way of solving a first order differential equation. But it's a really basic differential equation that everybody kind of starts out with, so I hope it kind of leaves you understanding like, oh, that's how differential equations kind of work. So if it left you with that, then I did my job. All right, thanks for watching me go through this book I got at Half Price Books.